Yes, we were discussing object-oriented programming system features, and we have discussed what are the different concepts when a particular programming language supports. Then you say it's an object-oriented, majorly encapsulation, inheritance, and polymorphism. Then we have discussed the design issues which you may probably encounter with when you are trying to fix this or implement these features, and how the different programming languages are addressing these issues as well. We have seen. And majorly taking examples of C++ and Java, we have seen, and we have seen how Java and C++ are implementing these features in what way they are differing and how far they are able to give you the object-oriented programming features and thereby giving a kind of facility for the programmers to come close to the nature and then able to solve the real-time problems. In similar lines, we will see a few more languages here. We just have a glance of all this programming language, object-oriented program features, right? The features that these object-oriented programming languages are supporting and in what way they are differing with other, and then how they are able to address the issues that they may encounter with an algorithm, right? So looking with C hash here, C hash is basically invented by Microsoft version or Microsoft company. You can see, and they have they have derived it through C++ features, but then combining some of the Java features, which probably look like very similar to Java, because Java was invented in 1995 by James Gosling and his team. The language invention itself was basically focused it to implement on the internet. So that way they have invented. So most of its features, if you see, they are more compatible with the internet, and it has become popular on internet within a very short span of time, and then it has got a good popularity over the internet. To beat the competition, to compete Java, Microsoft people have invented the C hash with a team of people, of course, rather, right? Taking C++ or object-oriented programming features into consideration, but which may look like very similar to Java, so that which can be rather easily implemented on internet and can be can compete with Java on internet applications, right? So looking at these features of C hash, look at the characteristics of C hash. It supports for object-oriented programming similar to Java. It includes both classes and structs. Right? Struct very similar to the rough structure of C or C++, right? So of course, as we know that the difference between structure and classes more looks to be the same, of course, rather, right? The structure will have only the members, but then if you add some function, then it becomes a class in C++. So this struct concept has been extended, in C hash here, rather, right? So by keeping both classes and structs in C hash, it was made available for the user. Classes are very similar to Java classes. Structs are less powerful, stack dynamic. They are less dynamic because here, like for example, when you wanted to have only certain data items to be part of the class instead of having some functions or more number of functions, then but in Java, if you see what happens, everything is considered to be a class itself, right? So if let us say you have very few functions, or you do not have functions or methods, then also you need to have a class itself, even with only certain data members, right? But if you look at class concept, is high performance. It takes time, and of course efficiency is good, but then it comes with some overhead, rather, right? Unlike struct is less powerful, so it can be efficiently, executed or implemented, or you can see doesn't take that extra overhead which class takes. So it's giving a provision to the users having both of these kind of features, so that the users, if they wanted to go with less powerful, objects, they can go with structs, and if they wanted to go with high performance or high powerful, then they can go with classes, right? Inheritance. Coming to inheritance, it uses the syntax of C++, because as I said, it is descendant of C++. So you can see the syntax is very similar to that of C++ when you are trying to implement inheritance in C hash. A method inherited from parent class can be replaced in the derived class by marking its definition with new. Okay, so if you have a parent class inherited, which can be replaced, here in the derived class, the marking test. We will probably see some examples here in the public slides. Right? The parent class version can still be called explicitly with the prefix base. So the parent class can be here called with the base keyword. So by just prefixing that, if you have draw method available or function is available in the base class, you can directly call that through the class itself, right? The base. Fine. So without creating an object, rather you have a keyword available as part of the C hash, which when you use it, you can access all the values of the base class. Dynamic binding. It allows dynamic binding of method calls to methods. The base class method is not virtual. Very similar to that of C++, you can see dynamic binding concept can be implemented in C hash, as I discussed in the last class. By taking an example, when you have in the base class virtual functions, they can be overridden in its derived classes, and the base class pointer can point to the derived class objects, and thereby they can access the methods of the derived class which have been defined by the derived class. And this is all going to be done during the runtime, since you have both functions. One is coming from the base and another one is derived, which will be unable to be differentiated rather by the compiler. So it will be left to the system, and the operating system will come into picture. And during the runtime, it takes care of binding these functions, to the base class reference, or the pointer rather, right? Where the base class pointer must be pointing to the respective derived class object, right? As the system knows that virtual cannot be implemented, so non-virtual is rather going to be binded. Okay. So and abstract methods are not. You have in addition to virtual, abstract methods also, like how you have it in Java. You have in Java the same dynamic binding concept. You can see it's being implemented with the help of abstract methods, right? So the base class methods are declared as abstract methods, because the base class is an abstract class. When you say a class is an abstract, when a class is having at least one abstract method. So when you inherit this base class, etc., and derived classes, these abstract methods are going to be overridden. And by creating a reference instead of pointer, because you don't have the pointers in Java, so you can rather have a reference objects, right? You can create a reference objects of the base class, and then you can assign it to the derived class object, and then thereby you can access or invoke the derived class methods, right? So, and over in Java, you can see of the all object creations and binding of method to object and all are being done during the runtime. So you can say this dynamic binding is efficiently rather implemented with the help of method in Java, right? All C hash classes are ultimately derived from the single root class called object. Okay. And of course, it supports nested classes. A C hash class that is directly nested in a nesting class behaves like a Java static nested class. Like how in Java we have seen anonymous classes also being possible. You can define a class without name with that implementation of its methods within the parameter of a method invocation as well, right? Which is rather being possible. The similar kind of approach is available in Java as well. So you can probably have the nested class. In Java, it is providing in a certain with a variety of features, rather, right? You can have class within a class, and then classes can be within package, and package can be within package, and all kind of thing that we have discussed in the last class, right? So similarly, C hash also it's providing the nested class concepts. It does not support nested classes that behave like the non-static classes of Java, right? It behaves like a Java static nested class. Okay, the difference between the static and non-static classes, as I have discussed in the last class, that static classes are the one can be called with the class name itself, because once you create a static class object, memory will be created once, and though you create any number of objects of the same, they are all going to rather point to the same memory, and they share the same memory, rather, right? So that is what the static class concept is. Basically, static variables also you must have heard about before, and I probably have discussed when I have rather discussed about the static variables. Generally, the hit counters and what do you call visits, number of visits on the website will be implemented with the help of static variables, right? Static classes will have static methods, and static methods will have static variables, right? So here you can see C hash directly support nesting classes, which behaves like in static nested classes. They cannot support the non-static classes of Java. Of course, Java supports both static and non-static in nesting, because Java is providing you a variety of nesting, of classes with even packages as well, right? But C hash is restricted to only static nested class. Okay. So now coming to evaluation, C hash is the most recently designed C-based object-oriented language. You can see why C hash is given, because most of its syntax is coming directly from the C itself, rather, right? Even C++ is an implementation of C, you say, right? And the C syntax is directly taken into the C++, where by just adding the object-oriented programming system features, it has been told as the C++. Similarly, C hash, if you can see, the C syntax is directly taken a transition to C hash by adding the object-oriented language. At the same time, it has been made compatible with the internet, right? The differences between C hash and Java, supports for OOPs are relatively minor, very minor, because C hash, when being implemented or invented, the other way I can say. So keeping in view of making it as an internet base, so most of the Java features were being taken into consideration here, because the time when C hash actually invented is invented keeping in view of giving a computation to Java, because Java at that time was most popular language on the internet, and C hash wanted to be made as an internet language, right? Now coming to Ada. Ada is also an object-oriented programming system, as I've discussed probably in the early classes as well. Ada is a lady, is a named after her. Basically, this is the first lady who wrote a program on the first computer, that is Abacus. Abacus is the first computer invented by Charles Babbage. Okay, and this lady is his friend's daughter. So she was the first to write a program on the first computer. So named after her, this language is available. As I told you, that this language is popular as and when new features evolved in programming sector, were being adopted to this Ada, and then make it as more updated. And you can see it is being used in air traffic management very effectively, because for real-time applications, Ada is more accurate. Because in real-time applications, accuracy is more important. So Ada is more accurate. So this is one of the you can say unfamous language. There are famous languages like C, C++, Java. You must be all aware of, rather, right? C hash and .NET, and probably Python, JavaScript, VB action script. All scripting languages, or probably Node Java we got nowadays, and probably other tools. A lot of tools are available which are quite famous for the your data science and all, like R, regression tools and all kind of thing. But then Ada is, of course, though it is unfamous, but it is more popular and more powerful language in real-time applications because of its accuracy. Okay. General characteristics of Ada, if you look at object-oriented programming, was one of the most important extension to Ada 83. Okay. As I told, the object-oriented programming scenario came after 80s around, right? Though the concepts were available before 80 as well, but then languages have not come, and then there were no language which probably got popular with the OOPS concept. Of course, like as I told you, Smalltalk was there, and Simula was there, and but then after C++ only came into being, people came to know that object-oriented programming systems concepts can be applied, and then we can bring all the real-time problem very closer to the machine and can be able to easily implement it, right? So that's how it's around 85, I think, John S. Ostrop who invented C++, after which, as I told you, that object-oriented programming system came into being and very familiar with the users, the real world scenario, right? So during the same time, of course, you can see they were being added to the Ada 83, and Ada 95 was invented, and it provides encapsulation. Of course, the help of encapsulation container is a package that defines a tag type. A tag type is one in which every object includes a tag to indicate during execution its type. The tags are internal. We'll see with the help of slides coming in the next next to it. Tag type can be either private type or records. No constructors or destructors are implicitly called here. Okay, like in C++ and Java, you can see constructors and destructors are called implicitly. Fine. Coming to inheritance, the subclasses can be derived from tag types. New entities are added to the inherited entities by placing them in a record definition. All subclasses are subtypes. It means all classes can be used as objects rather, right? No support for multiple inheritance. We don't have multiple inheritance here in Ada, like in Java also. But then with the help of interfaces, we are able to simulate and then bring that concept being made possible, of course, right? A comparable effect can be achieved using the generic classes. Okay, generic classes like templates we use in C++. In C++, we can have generic classes with the help of template that we have discussed in the previous classes, right? Now, looking at one example of the same with tag type, package person package is how you define a class in the form of a package with a tag type, right? So package you give then followed by the package name and is you're saying, then you're defining in that records you can have tag type, both you can have in this type. Person space person is tagged private, procedure display, p in out person private. I mean, you have the access specifiers here. You're trying to define the scope of the members of the particular tag type here, right? So under private, you're defining this type person is tagged, right? So you're defining here one record. The record, name. You're basically having record consists of name, address, and age, of course, right? So this record name is person. Okay. So this person record consists of a name. Name basically a type of string, carries 1 to 30 characters. Address is another field of this person record, carrying characters from 1 to 30. And then age, you have another field of this record, which is an integer rather, right? So we are defining a record here for person. So how do you define? You can see here type person. In this particular syntax, if you can see, is very much similar to Pascal, right? In Pascal also you define the records in the same fashion. Of course, the same when you come to C or C++, you are doing it with the help of structures, right? So very similar to structure kind of ADT. Okay, then you end the record, then you end the person package here, right? With person package, use person package. It means See, as I told you, subclasses are subtypes. It means the same name can be used as an object here. So here it said with person package, use person package, package student packages. Okay, then you're having another package here, student package, and then you are defining the student package here. Type student is new person with. So the student is inheriting the person record rather, right? Is new person with record. You can see grade point average, grade level, and the record procedure. You are having one procedure inside this as well. In addition to this particular record, where you are trying to display. So you are displaying the student details. Fine. ST is a variable of student. Student is a record kind. Okay. So this entire student record is going to be displayed when you invoke the display method. And student package. You're then ending the package, right? So here you can say this display is being overridden here, right? From the person package. In person package, if you have display here, you do not have. Yes, here you have, right? Fine. So this display package here you have just given as a procedure, and you said that it is person, but then this display is going to override. So if you are trying to display the person's information in this particular display, that also you can call here, and then you can probably display the details of student. But when you try to call this particular function through the object of the student, you will be able to do both the things, like how it is possible in C++. In C++ also it happens the same way, rather, right? So when you create an instance of a derived class, fine, the members of base class as well are going to be associated with a particular derived class object. It means the memory not only being created for the derived class object, but as well to the members of the base class. And when you have, let us say, some constructor being invoked by the destructor, by the derived class object, because when you create an instance, generally what happens, the constructor is going to be implicitly called in C++. But then the derived class constructor will first call the base class constructor, right? Then it initializes all the base class members. Then it will go for its own to initialize its own members. So that's how the same kind of scenario, rather, you can see has been here, repeated from the concept point of view, rather, right? And it supports dynamic binding as well. Dynamic binding is done using polymorphic variables called class void type here. For the tag type person, the class void type is person's class, right? So you can use class void as a keyword here, with the help of which you can probably use, if you have multiple dissidents of the person, so that dissidents can be defined with the help of class void, and then the person can refer to that dissidents, and then you can be able to implement those dissidents, rather, right? Being binded during the runtime, multiple instances, and then be able to execute all such different dissidents at the different times, right? Other bindings that it allows is static binding. Also, it allows any method may be dynamically bound here. No, methods are being basically bound here at the runtime itself. Purely abstract data, abstract base types can be defined in ADA 95 by including the reserve word abstract. You have abstract keyword like how you have it in Java. So the help of which you can probably define the abstract methods as well. If it's coming to the evaluation, because the ADA offers complete support for object-oriented programming system. It's a completely object-oriented programming system. You can say very similar to that of Smalltalk as Java. C++ offers better form of inheritance than ADA. Okay, ADA includes no initialization of object like constructors. You don't have it. When you do not have the constructor, there is no implicit call of constructor as well, right? So dynamic binding in C-based root language is restricted to pointers and or references to object. ADA has no such restriction and is thus more orthogonal, right? So if you see in C-based root language, dynamic binding is restricted with the help of is restricted to pointers or references, because here in C or C++, if you want to create the objects and get binded to the base class pointers, so or references. This all been possible only through the pointers and references only, rather, right? So it means dynamic binding is restricted to pointers and references, you can say, in C-based. Even Java is a C-based because most of the C syntax is directly taken by the Java. So of course it makes use of references, right? Java makes use of references, whereas C++ it makes use of pointers. Of course it does have references as well, so it makes use of pointers. But Ada has no such restriction and it does more orthogonal, right? This is all about Ada, and then coming to scripting languages. Basically, most of the scripting languages initially when they were started, they were object-based, of course, rather, right? But then later, in later cases, then they were being upgraded with some more features, and then maybe there are certain scripting languages which are object-based, right? So if you're starting with JavaScript is initially it was a object-based itself, like VBScript and all scripting languages, right? General characteristics of JavaScript is first see here. It is little in common with Java because how you call the objects, how you call the methods through the objects, and how you probably create the objects. You can see it is very similar to Java, right? I mean syntax wise also, if you see, it is more similar. And dynamic typing is there because you have objects, so objects are being created at the runtime. So dynamic typing is there. No classes are inheritance or polymorphism, right? There are no classes. You have only objects. You have, and later of course have been added as well. Okay, you got in the later versions. You got Node Java now. Fine, anyway. So if you can see JavaScript, you don't find classes. You can have methods. You can have methods, and you can invoke the methods through some objects which you probably imported from some libraries, rather, right? Inheritance, you don't have inheritance. You don't have polymorphism. Basically, a language who does not have inheritance or polymorphism, you say it's not an object-oriented, right? It is just an object-based. Rather, it supports the classes and objects, right? Variables can reference objects or can directly access primitive values, right? JavaScript objects, if you see, it's an object. So the object of JavaScript, you see, has a collection of properties which are either data properties or method properties. It can have both data and method. Appear as a hashes both internally and externally. A list of property or value pair. You find it as a value pair or just a property. Properties can be added or deleted dynamically. A bare object can be created with new and a call to the constructor for object. So object creation is very similar to that of Java, like you can see here at the runtime. So variable, whatever the variable you want to create, then new that object of variable, right? So references to properties are with dot notations. How do you access the properties of that respective object through the my object with the help of dot notation, which is basically widely used as a membership operator across many of the languages like C, C++, Java, and all, right? JavaScript evaluation, effective at what it is designed to be. It's a scripting language. At the point of a scripting language, it is quite effective. Basically, scripting languages, if you can see, this bash for operating system also, scripting languages are being used like Conch shell, Bourne shell, and all. You have for internet, many of the languages are script-based languages. You take PHP, Python, or you take ActionScript, VBScript, JavaScript. These are all scripting languages, right? But this JavaScript, if you see, is taking most of the features or syntax from the Java directly, right? And most of the Java libraries, you can directly access it through the JavaScript, right? Because there is a close relationship between the Java and JavaScript here, right? Because JavaScript is a descendant of Java, you can say. It is inadequate for large-scale development. If you are going for a large scale, then maybe it's not adequate. No encapsulation capability of classes. Okay, you don't have classes, so no encapsulation. Large programs cannot be effectively organized. No inheritance, so reuse ability is not there. So reuse will be very difficult. Implementing object-oriented constructs. Two interesting and challenging parts here. If you see storage structure for instance variable, how the storage of the objects that you will create at that time, for instances is one challenging thing. Basically, in Java you have memory management, of course, right? Dynamic binding of messages to methods. How the binding of the messages to the methods is another challenging issue. So these, of course, are being taken care with the kind of mechanism that Java has adopted, of course, right? Instance data storage. Class instance records store the state of an object. Static built-in compiler. If a class has a parent, the subclass instance variables are added to the parent class instance records, right? If a class has a parent, the class which you are trying to use it, the subclass instance variable are added to the parent class directly, right? Because here is static, access to all instance variable is done as it is in records, which is quite efficient. Dynamic binding of method calls. If you see methods in class that are statically bound need not be involved in the CIR. Methods that will be dynamically bound must have entries in the CIR. If they have the entries in the CIR, that is enough. They can be directly called. Okay, you have to bind it, to the, like how in C++ or Java we have seen it was being binded to the base reference pointer, right? Calls to dynamically bound methods can be connected to the corresponding code through a pointer in the CIR. Right. So internally, if you can see, it takes care of invoking the same with the help of CIR. The storage structure is sometimes called virtual method table. Right. The storage structure, which basically employed here for the creation of objects, is we calling it as virtual method tables, V tables. Right. Method calls can be represented as offsets from the beginning of the V tables. So they will maintain all the methods and objects, and also binding of the messages as well being taken care by looking up at the virtual table. So this is all about the object-oriented programming features and design issues that may probably the language designer must have to deal with, and how the different programming languages are dealing with these issues and trying to adopt the object-oriented programming system, and in what way they are different. We have seen taking different examples of the same, like C++, Java, Ada, Simula, Smalltalk, and we have taken some scripting like JavaScript. Okay, Okay, so object. Just take a review of the same. Going through this summary. Object-oriented programming involves three fundamental concepts. ADTs are encapsulation, then inheritance, and dynamic binding. Major design issues, if you can see, one is exclusivity of objects, subclasses, and subtypes, type checking and polymorphism, single and multiple inheritance, dynamic binding, explicit and implicit deallocation of object, and nested classes. Smalltalk, you can say, is a pure object-oriented language because you don't find any other thing, apart from objects. Okay, C++ has two distinct type systems, right? It will allow basically classes and as well as functions and simple data as well, right? It's a hybrid, you can say. Java is not a hybrid language like C++, but it supports only object-oriented programming. C# is based on C++ and Java. JavaScript is not an object-oriented programming, but provides interesting variation. So we can say it's a it's an object-based. Okay, JavaScript is not an object-oriented, but you can say since it mixes of the objects of Java, it has very similar syntax of Java. By importing the libraries of Java as well, you can say it is based on Java, so it is object-based. So that's how you can rather say. And here, stopping for